Okay, so question number 5 is CH3OH polar or nonpolar? So this is also known as methanol. And we can sketch out the Lewis structure of methanol as well, just to see whether or not it's polar or nonpolar. So to draw out its Lewis structure, we first need the total number of valence electrons. So for carbon, there's 4 valence electrons. For hydrogen, there's only 1. We multiply this by 4. And for oxygen, there are 6. So this gives us a total of 14 valence electrons. So now we can try to draw the skeletal structure. So the carbon will be bonded to the 3 hydrogens and another bond to the oxygen, and the oxygen can be bonded to the last hydrogen. So each bond contains 2 bonding electrons, and we have a total of 5 bonds drawn in the structure, so we have 10 out of the 14 electrons. So for the remaining 4, I'll place them as lone pairs on my oxygen, since oxygen didn't have a full octet yet. So now I have the Lewis structure for methanol, and we first need to look at the electronegativity values for carbon, oxygen, and hydrogen. So let me write all of the electronegativity values here. And this will help us determine whether or not any of the bonds are polar or nonpolar. So let's look at different electronegativity values for these atoms. Okay, so carbon has an electronegativity value of 2.5, hydrogen's is 2.1, and oxygen's is 3.5. So I'll just write here that we have a polar bond when the electronegativity difference is greater than 0.4 but less than 1.69. And we know we have a nonpolar bond when the electronegativity difference is less than 0.4 or equal to. Okay, so now let's calculate the different electronegativity value differences between our atoms. So first let's look at the carbon-hydrogen bond. Carbon has an electronegativity value of 2.5, hydrogen's is 2.1, so their difference is only 0.4, so therefore this is a nonpolar bond. If we were to look at the carbon-oxygen bond, oxygen's is 3.5 and carbon's is 2.5, so their difference is 1. So therefore this is a polar bond. And we can do the same thing for the oxygen and hydrogen bond. 3.5 minus 2.1 is even more polar, so it's 1.4. So now, if we were to write dipole moments in this molecule, we'll have them kind of gearing towards the oxygen like this. So since these dipole moments aren't able to cancel each other out, then we can say that methanol is a polar molecule. So this means it's able to dissolve in water if they were both in solution. Okay, so the junior tutor has a pretty lengthy description, so let me just try to graze through it. Okay, so they describe the difference between polar molecules and nonpolar molecules, and how you can find the electronegativity difference between the two atoms. Okay. They talk about hydrogen chloride, which would be a polar molecule since chlorine is much more negative, electronegative than the hydrogen, and it will lead to unequal sharing of the bonding pair. Okay, so they have some nonpolar molecules examples as well. And because a nonpolar molecule contains a symmetrical structure, the dipole-dipole moment is cancelled out. For the case of methanol, it has a bent structure where it forms an asymmetric structure, hence making the net electric dipole moment's negative end move towards the oxygen atom. Therefore, methanol is a polar molecule. Yep, so this solution is correct.